Now let's start by looking at direct proof. To give a direct proof of a conditional statement, P implies Q, we assume the hypothesis P is true, so we assume P is true, and then we go and show that Q follows. Okay? So let's look at the example. Use a direct proof to prove that if a number is odd, then its square is also odd. So we're going to start by assuming the number is odd. So let n be an integer, is an odd integer. Okay, so let n be an odd integer. If n is odd, we can express it as 2k plus 1. Okay, where k is an integer. Now this is a common process, and you'll see that as we do examples. So this 2k here has to be even because it's a multiple of 2. And then the adding 1 makes it odd. So it makes the even number odd. Okay, so that's why we can say 2k plus 1 has to be odd. Take that off so you can still see the 2k. Okay, so that means we've got n equals 2k plus 1. So we've assumed n is odd. We now need to show that the square of it is odd. So n squared would be 2k plus 1 all squared, which would be 4k squared plus 4k plus 1. If you can't see that, do it the long way. 2k plus 1, 2k plus 1, and using the distributive law. Okay, now you should be able to see we have this plus 1 on the end. So if we can show that 4k squared plus 4k is even, then we've shown n squared is odd. So let's bring out a factor of 2, and we've got 2k squared plus 2k, and then we have our plus 1. Now this must be even because it's a multiple of 2. And then the plus 1 makes it odd. Okay, so as 2k squared plus 2k must be an integer, because k is an integer, it follows that n squared is odd. So we've now proven that if a number is odd, then its square is also odd. And we're done.